Okay, hello everyone. Today we're looking at quadratic functions in factored form, or sometimes it's called intercept form, because it's really easy to see where it crosses the x-axis when it's in factored form. Now we've looked at factored quadratics before. All right, it's a product of factors. Express a quadratic as its product of factors. All right, today's objective, then we're going to learn how to graph a quadratic in factored form. The essential question, you'll need this for the homework check. How do we find the x-intercepts and the vertex of a quadratic in factored form? Because you need the x-intercepts and the vertex in order to graph it. Again, we've looked at two forms of equations for quadratic functions. We looked at standard form and vertex form. Again, this lesson, we'll take a look at factored form. And there's advantages to each form, as well as factored form. And if you look at these three quadratic expressions, all right, this first one here, just think of this y plus 4. Think of the 4 on the other side. This is vertex form. This next one here is factored form. Two factors multiplied together, the product of two factors. Two linear factors multiplied together give you a quadratic. And then this is standard form. This is the sum of terms. The sum of three terms, as long as there's an x squared there. Again, if we graphed them, we notice they look the same. That's because they are the same. They're the same quadratic equation, the same quadratic function, even though the equations, I'll say, are expressed different. All right, again, it's in fact the same parabola or the same quadratic function. And again, y'all, how do you go from vertex form to standard form? You multiply it out. Go ahead and multiply this out and combine like terms, so you write it as a sum of terms. You do the same for the factored form. You use the FOIL method or the box method and multiply this out. And then combine those two middle terms, because they're like terms, and you end up with the standard form. Guys, again, different key aspects are revealed by each form. Obviously, from the vertex form, you can easily find the vertex. Okay, because HK, it's displayed easily, HK. 3, negative 4, you can see it right here. Again, the opposite of what's inside, exactly what's outside. All right, in standard form, it's easy to see the y-intercept, that plus 5. It's hanging on the end there. Plus 5, that's where it crosses the y-axis up here at 0, 5. And for factored form, it's easy to see the intercepts, the x-intercepts. You see, when x is 1 here, 1 minus 1, that makes y 0. Or when x is 5 here, 5 minus 5, that makes this one 0, which makes y 0. Either one can be 0. All right, you can see where it crosses the x-axis pretty easily. Again, guys, that's kind of what this is saying here, the big idea. The intercepts of the quadratic function are easy to find, the x-intercepts, when it's in factored form. All right, again, you can see it right here. I put it in decimal so to show you. It crosses at negative 2, and it crosses at 3. And you can see directly in between those two, all right, would be the axis of symmetry. All right, it can be determined from the factored form the same way that the vertex can be determined from the vertex form. You can just look right at it, okay? As the reason it works, there's something called the zero product property. Guys, if the product of two numbers is 0, at least one of those two numbers must be 0. So if a times b is 0, well, then either a is 0 or b is 0. So guys, if we have a quadratic in factored form and a is not 0, then either r or x minus r must be 0 or x minus s must be 0. All right, so if x equals r or x equals s, then y is 0. And as an example, if the factored form is x plus 2x minus 3, then we know that when x is negative 2, this first factor is 0. And here when x is 3, this second factor is 0. And you can set each factor equal to 0 and solve for x. And you'll get the intercepts, negative 2 and 3. You can see that right here. Okay, guys, here's an example with the equation x plus 4, x minus 2. So this goes through at negative 4 and 2. And we're going to change the value of a. Here a is 1, and this one a is 2, and this one a is negative 1. It's upside down. Here's a is negative 3. We're changing the value of a. All right, you notice that the vertex changes. All right, the y-intercept is changing. But the x-intercept stays the same. The x-intercepts stay the same regardless if a changes. And you can see this better if they're all in the same graph. See, they all go through the same x-intercept. Changing the value of a does not change the value of the x-intercepts. Well, I guess I'm saying that right there, okay? Also, guys, the axis of symmetry, I mentioned this before, it always is located halfway between the two intercepts. All right, so you can just add those two up if you want. This is 4 and negative 2. You can add them up, divide by 2, and you get 1. Right? 4 minus 2 is 2. 2 divided by 2 is 1. The axis of symmetry is x equals 1. All right, again, and h is what we call the axis of symmetry. That's the x value of the vertex. Guys, because it always goes through the vertex, once it's identified, we can calculate the y-coordinate of the vertex by plugging it back into the original equation. So again, in this case, we had 1, where x was 1. All right, so we can plug it back in. All right, x is 1. Plug it in right here. Oh, I'm sorry, this is a different quadratic. Okay, it's upside down. All right, x minus 1 and x minus 5. So you can see the two intercepts is 1 and 5. Add those up, divide by 2. So x equals 3 is the axis of symmetry. So you can put 3 in right there where x is, and put 3 in right there where x is. All right, 3 minus 1 is 2, and 3 minus 5 is negative 2. You'll get that a lot. Don't forget there's a negative in front there. All right, so 2 negatives make a positive, and 2 times 2 is 4. So that's the y-coordinate of the vertex is 4. When x is 3, y is 4. And that's the vertex, and that's how you find it, okay? Guys, please complete the homework check. And the homework check, these are the questions that are in the homework check right there. All right, I have to stop now. Thank you.